Hi, so for today we are going to talk about factoring polynomials and rational expressions. In this video, we are going to continue our discussion about intervention for calculus drafting. So let's get started with factoring first. Okay? So the very first method of factoring is what we call the greatest common factor, commonly known as the GCF. So the greatest common factor of polynomials is the largest polynomial that divides evenly into the polynomials. So basically what we are doing with GCF it is that we are just factoring out common factors inside the polynomials that are common to all. Okay? That's the largest common to the all of the terms. So, if we determine what is the largest, okay, common factor among all the terms, then therefore from that, we can factor it out to simplify the given expression. So, here are the steps in the factoring out the greatest common factors. We have to identify the GCF of the coefficient, identify the GCF of the variables, combine to find the GCF of the expression, and to determine what the GCF needs to be multiplied by to obtain each term in the expression. And lastly, we have to write out the factored form or expression as the product of GCM and the sum of the terms we need to multiply by. So in order for us to understand it more better, we need to have examples. So for example, for these examples, no? So we have, for letter A, we have 6x cubed y cubed plus 45x squared y squared. And then we have 21xy. So what are we going to do with the greatest common factor is we are going to look, okay, at the factors relationship, okay, on the terms. So you have, for example, for the coefficient first, you have 6, you have 45, you have 21. Okay? So they share some similarities, okay, wherein we can factor this 6, 45, and 21 by getting the greatest common factor. And the greatest common factor will be 3. Since 6 is divided by 3 is divisible by 3, 45 is divisible by 3, okay? And 21 is divisible by 3. So that's the greatest common factor when it comes to the coefficient. Okay? So, and next one, we have x cubed, x squared, and x. So, the greatest common factor is they all have x. Okay? For the x cubed, we know that it can be written as x times x times x. That's the x cubed. Okay? And for the x squared, we know that that is x times x. So that is x squared. Okay? And they have all common x's. So I can factor out this x, okay, from all of the terms. How about for y? We have y cubed, we have y squared, and the same time we have y. So all in all, I can factor the same thing. We can factor out y because that is the greatest common among them all or among the terms. So I can factor 3, I can factor the x, I can factor the y. And that is multiplied to, of course, if I factor 3 here from the 6, that should become 2 because 2 times 3 will be 6. So if I factor x, okay, what will become x cubed here? If I factor 1x, so that would become x squared. And if I factor 1y here, from the y cubed, that would be y squared. So that if I distribute, okay, this will be the result. Okay? If I distribute 3x to y. And that is plus, okay? Moving on to the second term, we have 45x squared y squared. So, 45 divided by 3, that would be 15. So that if I multiply 3 and 15, that would be 45. So, I factor out 1x here, okay? So, this x squared becomes x, okay? Because I factored out 1x, okay? And also, for the y, I factored out 1y, so that would be simply just y. And last but not the least, we have 21xy, wherein I factored out 3, so this becomes 7, because 7 times 3 would be 21, And the xy here, I factored it out. So that's why I don't have anything to write here because I factored it out already. 1x and 1y. So that if I'm going to distribute 3xy into this expression, I'll be going back to the same original form. Okay, so that's how we do the greatest common factor. Right, moving on to the second one. You have x quantity b squared minus a, and then you have plus 6 quantity b squared minus a. This is pretty much easy. We know that in both terms, we have quantity b squared minus a. So if we have quantity b squared minus a, we can factor that out because that is very, very much common, same common on the both of the terms. So you have b squared minus a, and then you have, you factored out b squared minus a, so you have, all you have is x plus 6. Okay? So you factored out b squared minus a. Okay. So, next is 14x plus 4xy minus 18x squared y. So, first, we have to clarify or get the greatest common factor for the coefficients. So, we know that that is 2. Okay, it's not 4 because 14 is not divisible by 4. Okay, neither 18. So, we have 2. So, I can factor out 2. Okay, 2 in here. So, and by the way, we only have 14x in here, and we have here 4xy. Okay, so I think we'll have to group it. Okay, in terms of these two that only has xy and xy, but this 14x, okay, still we are going to write it as it is. So you have 14x plus, I'm going to factor out 2 here, 2, and then I have to factor out xy because it's both appearing on the 4xy. So, let me just rewrite. I have 14x plus 2xy factored out. Okay, so that now I have 2. So that if I multiply 2xy with this, that would be 4xy minus 9 y only. Okay, so that if I'm going to factor this out or distribute 2xy times 2, that would be 4xy. 2xy times 9y, what that would be negative 18 xy squared. Okay, so this will be my final answer for this. All right, that's how we can factor it up. Okay, so I leave you these examples for your solutions. Okay, so you can factor out here. Let's say all of the terms have common here. Okay, you can factor out m. Okay, because they are all common, the greatest common factor. And if there are numbers divisible by 49, okay, 7. Okay, so let's try. Okay, 49 would be actually what? Okay, that would be actually 7. Okay, and at the same time, this is negative 35. So still divisible by 7, and 77 is divisible by 7. So you all have common m squared, and m. Okay, so you have factored out 7 m. Okay, so 7m, factored it out. So that's common to all of the terms. Okay, so you have 7, and then 7m here, 7 times 7, that would be 7, 49. And then you have b squared, so that if you multiply 7m and 7b squared, that's 49mb squared, minus 35. So what number when multiplied by 7 becomes 35? That is 5. Okay, and then you have another m squared here where you factor m here, so I only have m here. And then of course you have ba, and then plus, okay, 77 divided by 7 would be 11 times 7, that's 77. Okay, you factored out m here. So I only write a squared here. Okay, so you have 7m, 7b squared minus 5mba plus 11a squared. And also, I forgot in letter C, okay, we can factor still out, okay. Let me just correct this for letter C. So for letter C, we have 14x plus 4xy minus 18xy squared. If you're going to factor it, the greatest common factor, so you can factor it by all of them have common GCF for the coefficient and x only. They're all common in the terms. So I can factor out 2. So I have 7. Okay. I can have 2x because x is common to them all. I can factor out 2x. 2x times 7, that's 14x. Plus 2y minus 9y squared. Okay. So 2x times 7 is 14x. 2x times 2y is 4xy. 2x times negative 9y squared is negative 18xy squared. So this will be the final answer. So please disregard this one. Okay. So that's the one that we have solved a while ago. And lastly, for letter E. So for letter E, we have common, what do you call this? Common factors, okay, for 35, 30, 45, and 135. So let us see if 135 is divisible by 15. Because I think 30 is divisible by 15, 45 is divisible by 15. Okay, and I think 135 is also divisible by 15. So 15 times 9 is 135. So they all have a greatest common factor of 15 for the coefficient. Now how about for the xy? So they have x as common. Okay, they have y as common. Okay, so we have to factor out 15xy. Quantity, 15 times 2 would be 30. So I factor out 1x and 1y. So this will become y squared, x squared. Okay, and I'll leave it as it is because I already factor out y. So minus, let's go to 45. 15 times 3, that would be negative 45. I factored out 1x. So this will become only x. I factored 1y here. So this becomes xy. And lastly, plus 9. Because 15 times 9 would be 135. And I factor out 1x. So I need not to write x here already. And I factored out 1y for the y cube. So you have y squared. So that if you distribute 15x to y, okay, into this term, this becomes what? The one shown here. Alright? So that is for the greatest common factor. So again, you'll just have to look for the common factors appearing, okay, the greatest common factor appearing, okay, in the terms so that you will be able to factor it out. So, factoring a trinomial with a coefficient of 1. Now, when we say trinomial, trinomial has 3 terms, okay? So, a trinomial at the form of x squared plus bx plus c, where b and c are constants, can be written in the factor form as x plus p and x plus q, where pq equals c and the p plus q equals b. Okay? So, I'll show you later what this p and q is. Okay? So, if we have a trinomial with a coefficient of 1, we can use this formula x plus p, okay, and x plus q, okay, where pq would be equal to the constant and p plus q would be equal to the middle term, which is b. Okay? So, let's try. So, for example, in this x squared plus 2x minus 15, if you're going to identify, the b here is 2 and the c here is negative 15. We say that we can factor this out, x plus p and x plus q, okay, in the condition that p and q should be equal to c and p plus q should be equal to b. So, we have a b here, the coefficient of x, which is 2, we have a c here, the coefficient is, or the constant is negative 15. So to factor this x squared plus 2x minus 15, we're going to look at this condition, pq equals c and p plus q equals b. What two numbers, okay? What two numbers that when we multiply, it will result to negative 15, and when we add, okay, when we multiply, it will result to negative 15, and when we add, it will result to 2 at this example. Okay, so there are many factors of negative 15. So you can have negative 3 and 5. You can have 5 and negative 5 and 3, correct? So you can also have 15 and 1, okay? You can have negative 15 and 1. I'm sorry, 15 and negative 1. So let's try 3 and negative 3 and 5. Okay? So if we multiply negative 3 and 5, okay? Because that's the requirement, PQ equals negative C or C equals negative 15. So if we multiply, it results to negative 15, which is correct, okay, for the PQ equals C. Now, how about if we add 5 and 3? So we have negative 3 plus 5. The result should be positive 2. So, did we meet this necessary condition? If and only if we meet, okay, the two conditions, that is the factor. So, Viola, we have 2 when we add these two numbers and negative 15 when we multiply. Okay? So, definitely, x squared plus 2x minus 15 can be now factored as x plus p, okay, plus or multiplied by x plus q, wherein our p would become x plus, let's say, 2, and our q would be x minus 15. Okay? So, x minus, x minus, sorry. So, I have, so this should be x minus 3 and x plus 5. So, x minus 3 and x plus 5. Because that is the factor that would make, okay, negative 3 times 15, 5 would be 15. And negative 3 plus 5, that would be positive 2. Okay, so the factored form would be x minus 3 and x plus 5. So if you FOIL that, you will be getting the same result as this. Okay? How about for number 2? We have x squared minus 7x plus 6. So we know that the PQ should be equal to 6. P plus Q should be equal to negative 7. Okay? So what are the two numbers? When we multiply, it will produce positive 6. When we add, it will produce negative 7. Okay? So you can think of the factors of 6. Okay? So it can be what? 6 and negative 6 and negative 1. Because negative 6 times negative 1, that would be 6. And negative 6 plus negative 1 is negative 7. Okay? So, the factored form should be x minus 6 and x minus 1. Okay? So, to check, you can FOIL it. First, x times x. Okay? Outer, negative x. Inner, negative 6x. And last, negative 6 times negative 1 is positive 6. So, you have x squared minus 7x plus 6. So, hence, this will be our answer. Okay? That's how you factor a trinomial with a coefficient of 1. Okay? Oh, how about factoring by grouping? Okay, to factor a trinomial in the form of ax squared plus bx plus c by grouping, we find two numbers with the product of ac and the sum of b. So we use these numbers to divide the x term into the sum of the two terms and factor each portion of the expression separately, then factor out the GCF of the entire expression. So from the word itself, factoring by grouping. Okay? So for example, your trinomial doesn't have a coefficient of 1. Okay, but it's not 1, but it's 2, 3, or any other coefficient. So we can just simply use the formula AC and the sum of B. Okay? So, let's try. So, how about this? If we factor 5x squared plus 7x minus 6, you can notice that the coefficient of x squared here is not equal to 1. So definitely we are going to have factoring by grouping. And how does that work? So if we have 5x squared plus 7x minus 6, the very first thing that we're going to do, we need to understand the coefficient of this. Let's label it as A. The coefficient of x should be labeled as B. And the coefficient or the constant term should be labeled as C. So what are we going to do is we have AC. We have to multiply A and C. That in that case, that would be 5 and negative 6, which is negative 30. So now, you are going to think of two numbers such that when we multiply, it should be negative 30. And when we add, okay, it should be 7. Okay. So negative 30, of course, we can have 10 and negative 3. Okay, so when we multiply this would be negative 30. Okay, there are many factors to 30. 5 and 6, negative 5 and negative 6. But I just think of 10 and negative 3 so that if I multiply 10 and negative 3, that would be negative 30. And if I add 10 plus negative 3, that would be positive 7. Okay? So, if I factor this out, okay, that would be, okay, I will be replacing this middle term. Okay, 5x squared plus 7x minus 6. I will be replacing this middle term with 10x and negative 3x. So, let's see. So, 5x squared minus 3x coming from here plus 10x. Okay? So, notice that we didn't change the original. Because if we simplify negative 3x plus 10x, that would still be 7x. So, we didn't change anything. We just get the factors. Okay? So, and you have negative 6. Okay? So now we can group. Okay? If I group the first two terms, that would be they have common x. So I can factor out x. Okay? And now you have 5x minus 3. Alright? So that is your 5x minus 3. I factored out x and x only because it's common to these two. And I can factor out also here 10 and negative 6, 2. So that would be plus 2 times 5x minus 3. Okay, so that if I factored out 2 times 5, that would be positive 10x. And then multiplied by negative 3, that would be negative x. So now I have common 5x minus 3. So that would be 5x minus 3. Okay? And then x plus 2. So that would be the factor. Okay? So these are both common, 5x minus 3. So you can factor it out and you can leave x plus 2. That is factoring by grouping. Alright? So let us try. Okay? So let us try here. So you have 2x squared plus 9x plus 9. Of course, we want the AC. And the AC would be 2 times 9. That would be 18. So what two numbers, if we multiply, that would be 18. And if we add, that would be 9. Of course, 6 and 3. So you have numbers 6 and 3. Okay? You multiply 18, you add 9. So this is what we are going to factor. So 2x squared plus 6x plus 3x plus 9. Okay? So we replace the middle term by 6x plus 3x, which is technically still 9. So factor. So you factor out 2 and 6 here by 2. And you have factor out x here because they are all common. So you have 2x. And therefore, we have only x because 2x times x would be 2x squared. Plus you have 6x. So you have 2x plus 3. So 2x and then x plus 3. So that would be 6x. Okay, how about this? 3x and 9, I can factor out 3. and leaving x and factored out 3 from 9, that would be 3. Okay? So, as you can notice, both x plus 3 are common. So, we can factor it out. So, this become x plus 3 and then 2x plus 3. So, this is the factored form. So, for letter B, we have 6x squared plus x minus 1. Okay, we know AC would be 6 times the negative 1, which is negative 6. Okay? So, what two numbers that if we multiply, that's negative 6. But if we add, that is positive 1 because of this. Okay? What two numbers if we multiply negative 6 and the answer is positive 1? So, shall we try 3 and negative 2? So, because 3 and negative 2 is negative 6 if we multiply, but 3 plus negative 2 will be 1. So, that would be 6x squared plus 3x minus 2x minus 1. So, we just replaced the positive x or plus x here by 3x minus 2x, which is technically still x. So, factored it out by grouping. So, you can factor x here and 3. Okay, so you have 3x, so that you have 2x, okay? And then you factored out 3x, so that must be 2x plus 1. Okay? So, same here. Negative 2x and negative 1. Okay? So, if I try to factor out the negative between them, so this will become 2x plus 1. If I factor out the negative 1. Okay? So, now, your result will be 2x plus 1 is common to both of the terms. So, you have 2x plus 1 multiplied by 3x minus, of course, 1. Okay? So, this will be 1. The 2x plus 1. Okay? So, that is factoring by grouping. So, factoring a perfect square trinomial. A perfect square trinomial can be written as the square of binomial, wherein we have a squared plus 2ab plus b squared equals a quantity a plus b squared raised to 2. So, that is the perfect square trinomial. Okay? So, wherein if we can rewrite it as the square of the binomial. So, meaning, okay, a plus b here would be a plus b and a plus b. If we can rewrite it as a plus b squared, then this is a perfect square trinomial. So, how do you factor a perfect square trinomial? Given a perfect square trinomial, factor it into the square of a binomial. Confirm that the first term and the last term are perfect squares. So, if the first term and the last terms are perfect squares, then definitely that would be a perfect square trinomial. Confirm the middle term is twice the product of AB. Write the factored form as a plus b squared. So, given this example, for example, you have 25x squared plus 20x plus 4. So, the very first thing that you're going to do is to confirm if the first term or a and the last term, the constant, is a perfect square. So, let's say a squared equals 25, okay, x squared, and then the b squared equals 4. So, they are all perfect squares. So, such that if I take the square root of both sides, that would be 5x. So, you have an a of 5x. And square root of both sides, you have b equals 2. So, if you do that, okay, you are going to multiply a and b. Okay? The two last term, or the first term and the last term are squares, which is a check. Okay? But how you are going to confirm the middle term is this. Once you get the value of a and b, you multiply it. So that is 10x. And you further multiply it by 2. If that will result to the middle term, let's say 10x and 2, that's 20x. If that is equal to the middle term, then definitely that is a perfect square. And we can just simply write what? 5x plus 2 squared. Alright? So that's the factored form. Okay, for letter B, we have 49x squared minus 14x plus 1. Again, same concept. So you have a squared, which is 49x squared, and you have b squared as 1. So get the square root. So you have a equals 7x, and the square root of 1 is still b equals 1. To check the middle term, okay, so you are going to check, okay, the middle term in here, okay, if that is what? 7x times 1 is 7x times 2, okay, that would be 14x, which is, we can see here, 14x, but it's a negative 14x. So don't worry, it's just mean that 7x, since the middle term is negative, so you have a negative middle term, or the negative sign, or minus sign, and then you have 1 squared. Okay? So that would be 7x minus 1 squared. That's factoring out the perfect square trinomial. Alright, how about factoring a difference of squares? Okay, so a difference of squares can be rewritten as two factors containing the same terms but opposite sign. Okay, so if we ever see a squared minus b squared here, we can always factor it out by the quantity of a plus b and the quantity of a minus b, such that this a squared minus b squared doesn't have any middle term. Okay, because when we FOIL this, we have first a squared, outer, that's negative ab, inner, a times b, plus ab, and last, positive b times negative b, that's negative b squared. We can see that this will cancel. So that will result to a squared minus b squared only. So given the difference of two squares, factor it into binomials. We must confirm that the last and first term are perfect squares. So before we can actually conclude that it is what? A difference of squares. So write the factored form as a plus b and a minus b. So let us try. So factor the following using the difference of two squares. So you have letter A, 9x squared minus 25. So as you can see, both 9x squared, let's say that is a squared, and we have b squared, excluding the sign. So you have a squared, you have 9x squared, and you have b squared, which is 25. That is your b squared. If you get the square root, so you have a, we have 3x, and we have 25. Square root of 25 would be 5 and b. So it's actually good. Okay, we've gotten the a and b, and the formula would be a squared minus b squared. A while ago, that would be a plus b, and then multiplied by a minus b. So we just simply rewrite this as, we have the a, we have the b, so you have a plus b, so 3x plus 5, and that would be 3x minus 5. So if you FOIL this, you will be arriving at the same answer. Okay? So how about for letter B? So you have, for letter B, we have 81y squared minus 100. So this would be your a squared. This would be your b squared. So you have 81y squared. That's, your a would be 9y. Getting the square root of 81y squared, both sides. And your b squared would be 100. So your b would be 10. So your b would be 10 here. So you can write it as a plus b. So you have 9y plus 10. And then you have 9y minus 10. That will be the factored form using a difference of two squares. Alright? Okay. So the sum and difference of two cubes. Let's now go to the sum and difference of two cubes. So if we have the sum of cube, we have this formula, a cube plus b cube. That would be a plus b quantity multiplied by a squared minus ab plus b squared. So notice that we have a minus here if we have plus, and it also follows here that if we have plus, we have an a plus b factored. And if we go to difference of two cubes, so your first factor would be a minus, but all of your trinomial here would be a positive. So that is very easy to memorize. Okay? So, if we ever just see, okay, a factors like this, wherein they are, we can easily get the cube root of a and b, then most probably that is a sum of difference. Sum and difference. Either a sum or a difference of two cubes. So, we are going to confirm first if the a cube can be, we can get the cube root and at the same time the constant term. So before we can get the factored form. Okay, so let us try. So for this, factoring the sum and difference of cubes. So you have x cubed plus 512. Okay. Most probably, your a cube here is the x cube, which is if you get the cube root, both sides, that would be a equals x. So it can be noted that it can be factored out into cubes. How about 512? Okay. So the cube root of 512, let's say, if we get the cube root of 512, that's the cube root. Okay. So canceled, you have b equals 512. I think that's 8. 8 times 8 is 64. 64 times 8, that's 512. So let's try 64 times 8. 32, 3, 40, 48. Okay. So 512. So you have 8. So your values here for letter A of A would be x and your B will be 8. So since this is a sum, the formula of the sum would be A cube plus B cube. The formula would be A plus B, okay, multiplied by A squared minus, okay, minus 2 or minus AB plus B squared. Okay, going back to the formula to check, we have A plus B, A squared minus AB plus B squared. Okay, so now we can rewrite it as what? So that would be A plus B. So you have x plus 8, which is your B. And then you have A squared, which is x squared minus AB. So you have 8 times x plus the B squared plus 8 squared. So now you have x plus 8, okay? Then you have x squared minus 8x plus 64. Now that's the factored form for the sum of the two cubes. Okay? So that's the factored form. Okay. So how about for the letter B? So for letter B, you have 2/16 a cube as your do you call this as your a cube. Okay? So that's the formula, a cube. So it happens also that your variables here are a and b. Okay? So but can we cube 2/16 a cube? Okay? Can we cube that? All right? So can we get the cube? Certainly, yes. Okay? Because if we have 4 times 4, 16. No, that's not 16. That's 6. So if you have 6 times 6 times 6, that's 6 times 6 is 36. 36 times 6 is 36. You have 3 here. 18. So you have 2/16. So, and the cube of a cube would simply be a. And the cube root of 2/16 would be 6. So that your value of a here would be 6a. Okay? How about your b? It's very simple. The value of your b cube here is b cube. So your value of b is still b. Okay? So again, this is a sum of cubes. So now you have a plus b. So what is your a? That is 6a. So that is 6a plus b, which is simply b. Okay, and then you have, okay, then you have a squared. From the formula, you have your a squared. What is a? What is your a? That would be 6a squared minus ab. So you have 6a times b. You have the formula here, ab. So 6a times b plus the b squared, which is still simply b squared. Because your b here is simply the b. So you have now an answer of 6a plus b. You have squared, which is 36a squared minus 6ab plus b squared. So this will be your answer for the factored form. Okay, so for letter C, let's try. For letter C, we have 8x cubed minus 125. It's pretty easy. So this is your a cube, which is 8x cubed. This is your b cube, which is 125. So obviously, if you get the cube root, that would be a equals 2x. Okay? Cube root of 8 is 2. Cube root of x cube is x. Cube root of 125 is simply 5. Because 5 times 5 is 25. Times 5, that's 125. And take note, this is difference. So for the difference formula, we have seen it, a cubed minus b cubed. So that you have a minus b. You have a squared plus ab plus b squared. Okay. So we can rewrite a minus b. So that would be 2x minus 5. Then you have a squared, which is 2x squared plus the ab, which is 2x times 5. Okay, and then b squared would be 5 squared. So that you have 2x minus 5. Let me just rewrite. So you have 2x minus 5. And then you have 4x squared plus 10x. So 4x squared because of 2x squared. And then you have plus 25. Okay, so this will be your factored form for the difference of the cubes. And last but not the least, you can do this. Okay? So your a here would be 10x. And your b here simply would still be 1. Okay? And this is difference of two cubes. So 10 is the a because 10 times 10 is 100 times 10 it's 1000. So you have 10x as your a and the cube root of 1 is still 1. So you can rewrite using this formula. So let's rewrite. So for letter D, the answer should be a minus b, that is 10x minus 1 multiplied by a squared. What is your a squared? If you square this, that would be 100x squared minus a times b, 10x times 1 would be, or that is plus, I'm sorry, 10x times 1 would be 10x. And then the b squared will still be 1. So this will be your answer for the factored form for letter D. I don't have much space, so I just do the shortcut so that using the formula. Okay? So I think that's all for this video. On the next video, we're going to talk about rational expressions. So if you enjoyed this video, please don't forget to subscribe and to share my YouTube tutorial in your with your classmates and with your other engineering students so that they will be able to cope up with their intervention for calculus subject. So again, this is Engineer Abat. Thank you so much for listening. Again, see you on the next video about rational expressions. Thank you so much and God bless.